Okay, so today's lesson is going to be again about electricity generation, but we're going to look at all the different factors into why people choose different sources of electricity. So the cost, the environmental impact, does it need a special location, all that. So over here we have the types of power that the US uses. So I've actually split up natural gas into two different types. So there's the combined cycle, which I showed you the previous video, that it actually has a gas turbine and a steam turbine. So the exhaust gas from the gas turbine powers the steam turbine, and natural gas as just the gas turbine. And there's coal, nuclear, wind, hydro, looks like with dams, solar, biomass, and geothermal. Okay. So the first thing we're going to look at is the price. So if you took a look at your parents' electricity bill, you'll see that a certain number of kilowatt hours were used, and they're charged a certain amount for those kilowatt hours. Now, these prices are what the power plant gets. So if you were to look at a bill, they would be significantly higher than this. So we can see here that wind and solar are two of the cheapest that we have. And then there's natural gas and geothermal. And at the very top, we have biomass and then nuclear. And you can see coal is pretty high up there too. So you might be wondering, well, why don't we just use wind and solar? Well, again, that's because if we need a certain amount of base load power, natural gas combined cycle can do that, coal can do that, nuclear can do that, geothermal, if in the right spot, can do that. So this is why natural gas is our number one source of electricity. It has a very low price, and it can be used for baseload power. Okay. For intermediate or load following power, that could be natural gas combined cycle, natural gas, just a gas turbine, nuclear, hydroelectric, biomass, geothermal. Okay, so again, we use a lot of natural gas. Okay. And for peak, we have natural gas, just a gas turbine. Because remember, if you only have the gas turbine, you don't have to worry about the steam turbine. You don't have to worry about heating up all that water. So it can be turned on and off very quickly. Same thing with a hydroelectric power plant. And you can open up the sluiceways for water very quickly. And same with biomass. You can feed in the biomass at whatever rate you want. And lastly, intermittent. So wind and solar, even though they're the cheapest, okay, they're intermittent. So we don't have any control over them. So if you ever see an article that says solar and wind are the cheapest, we should just switch to all that, it's not currently feasible to do that just because of making sure that the grid stays stable. All right, next we'll look at renewables. So natural gas, either one, is not renewable. Okay, same thing with coal. They're fossil fuels. Nuclear, also, as it currently stands, is not renewable. Okay, there's only a certain amount of uranium that we can mine. And lower down, wind, we're never going to run out of wind. Hydro, as long as you can wait for the reservoir to replenish and fill it back up, it's renewable. Solar, okay, that's not going to run out. Biomass, you can always grow more. And geothermal, this planet's not going to cool down anytime soon. Okay. Next, we have greenhouse gases. And so obviously the renewable ones, they don't produce any net greenhouse gases. Okay. Nuclear doesn't either. So this is why some people want to switch more to nuclear, because even though it's not a renewable resource, it doesn't produce any CO2. Okay. Now, if we look at natural gas and coal, they both produce CO2, but in varying amounts. So coal, it produces around 915 grams per kilowatt hour, so that's about 2 pounds of CO2 per kilowatt hour. And you can see that just using a single gas turbine for natural gas, it's about 40% less. And if you use a combined cycle, because it's more efficient, you'll actually end up with less than half of the CO2 being produced for the same amount of power. And this is actually why the amount of CO2 that the US has been producing has actually been going down over the past decade, even though we're producing more power. And the reason for that is because we've been switching over from coal to a lot more natural gas. So even though we're still using fossil fuels, we're still producing CO2, we're producing that electricity with a lot less CO2. Then there's location. So natural gas, coal, nuclear, they can be situated pretty much anywhere. Okay, they don't need any special locations. Wind, you either have to put it offshore or at some high elevation so that there's a relatively constant source of wind. Hydroelectric, okay, you basically need a river and a valley because you need some type of waterway and you need to be able to dam it. So that means that you need to be able to fill up a big valley with water. Okay, so that only certain places allow for that. Solar, that has to be somewhere sunny and, if possible, at a lower latitude. That's because the angle of the sun is a lot higher in the sky the closer you get to the equator. Okay, for biomass, you need cropland to grow the fuel. So that could be, soybeans for biodiesel. It could be corn for ethanol. But you need that land. And lastly, geothermal. So for geothermal, you either need to be near hot springs or near tectonic boundaries. So hot springs, okay, those are only a few places that actually have hot springs near the surface. And tectonic boundaries, you get some pushback if you want to put a plant near any tectonic boundaries because usually fault lines for earthquakes are in the same area. And when you talk about pumping, tons of pressurized water, down into a tectonic boundary or a fault line, people get concerned about earthquakes. And finally, other pollution. So besides CO2, what kind of other pollution do these produce? So, in case you're wondering, NOx and SOx, that's nitrous oxides. So molecules that contain nitrogen and oxygen, and sulfur oxides. So sulfur and oxygen. Okay, the X is because it could be just NO, it could be NO2 or NO3. That's why there's the X's there. So natural gas does produce low amounts of nitrous oxides and sulfur oxides. Okay. So those are the main ingredients in smog. Okay, but natural gas, it's very low levels. Okay, coal, okay, produces much higher levels of those. It also produces enough of these to even cause acid rain. So that those sulfur oxides can react with water and actually produce sulfuric acid. And a couple decades ago, there were a lot of lakes in New York State and the rest of the Northeast that were actually dead. Like there was no life in them because of all the acid rain that we were getting from coal plants out in the Midwest. So that nitrous oxide and sulfuric oxides would drift over the Northeast, and then it would rain down as acid rain and kill off a lot of the lakes, streams, ponds. So luckily, we've been able to kind of reverse that in the past decade, and we're still progressing in that. Now, here's one you might not have thought of: radioactive waste. Okay, and you might think coal. Well, why is there radioactive waste in coal? And that's because coal has impurities. Okay? And once you burn off all that coal, all of those impurities are left over. And a lot of those impurities happen to be radioactive. So fly ash, that's the stuff that is left over after burning coal, actually it has a significant amount of radioactivity. And so much so that the background levels of radiation around a coal plant are actually higher than the background radiation levels around a nuclear plant. Okay? and that leads me into nuclear. So really the only byproduct of nuclear power is radioactive waste. Okay, there's nothing that goes up into the air, but you do have these radioactive elements that currently are just being stored. Okay? And there used to be a plan to actually bury them 10,000 feet below the surface in a place called Yucca Mountain. And I actually worked on that project before I became a teacher. I was part of a group that were designing the shipping containers to ship all that radioactive waste across the country. But eventually that project got closed down. So we're still just kind of storing all of our nuclear waste at power plants. And again, places like France that have been using nuclear power for decades, okay, they actually can even recycle some of their nuclear waste into new fuel. Okay. And with wind, there's no other pollution. Hydro, really no pollution. Solar, obviously none. Again, biomass and geothermal, again, you're not really releasing anything new into the environment. Okay, so you can see here that there is no one perfect source of energy. Okay, so if you ever hear someone saying like we should just do all nuclear or all solar or whatever, it's not that simple. One thing I hope you do see is that coal is probably the worst. The price is relatively high. It can be used for baseload, but not for load following or peak. It's not renewable. It produces the most greenhouse gas of any of them, and it produces the most pollution of any of them. So, if you take away one thing, coal is probably the worst one, and that's why the amount of coal power that we've been producing has been decreasing every single year. We used to produce more than half of our electricity with coal. Now it's under a third. So that's probably going to keep on decreasing over the next decade or two until it's actually phased out. So hopefully with a table like this, you can see, well, these can be put anywhere, but they also, not renewable. These need specific places, but they are renewable. So there's a trade-off there. And like with most things in real life, especially with engineering, there's always going to be a trade-off. There's always going to be some price you have to pay to get something else.